Our first steps in DNA sequence analysis with Python will be around analyzing strings and learning how to deal with strings in Python. So that's really the core of the matter. And we will look at this function here, find ATG, and the main thing we will try to analyze and understand is this for loop here. We're not worried about the if statement yet. All we want to see is how can we cycle through and find each codon for each frame in the DNA sequence. And yeah, we'll go through this slowly. This is quite nifty, but this is a great sort of first way to see the power of using simple code to identify patterns using Python. Right, let's quickly review. In the last lecture, we talked about data types and already talked a bit about strings. So remember the basic 4 data types: integers, floats, strings, and booleans. And strings have got quite a few methods of their own. So if you have a string like a DNA sequence like this, you always enclose it into the double quotation or single quotation marks. Strings are actually quite similar to lists in many ways. You can iterate through them. You can extract the length. So if you say length DNA, it'll give you the length of the string. And you can use indices to extract individual letters. So it is working very similar to a list, which is fortunate because actually working with strings now will also reinforce practice to work with lists. So we catch 2 birds with 1 stone. So lists, as you remember from last lecture, we can use these indexing techniques to extract individual parts of the list, and very similar in strings. We can use indexes in square brackets to then get like the first one or the second one, and also get a range of letters in the string. We can add things, we can multiply things. Multiplication of a string will lead in the duplication of the string or the triplication of the string, not a mathematical operation, obviously. And we can check whether something is in the DNA. So is ATG in the DNA? That would be a good test initially, for example, to see whether it's worth bothering doing that analysis in the first place. If there's no ATG in the string, no need to do it. Okay. So let's practice this a little bit. So here we have got a sequence, and I give you a few examples, and then we'll do some practice in the next section. So if we do 0 to 3, remember Python always starts with 0. So 0, 1, 2, 3. Will we get 4 or will we get 3 letters? Which letters will we get here? Maybe pause the video for a little bit and think about it. And also for the 1 to 4. And we will get ATG and TGC. I actually ran the code before, so it was already there. So you already saw it. So always we're starting with the first. So we're getting the letter from index 0. And then the colon here says, okay, give me the range up until the index 3 here, which is the 4th letter. So we get ATG. Or here we start with the first one. We start with T and then go up until the 5th letter, which is G. So we get TGC. Okay, this may seem a little bit confusing, but this is why you need to practice to get a handle of this. And soon it'll become quite clear and second nature to do this. So let's do this practice now. So we've got a few challenges. The first one is very simple. Let's do that one together. Complete, so let's get the last 3 bases of the DNA sequence. So let's say print DNA square bracket, and then we need 0, 1, 2, 3, 4, 5. And then actually there's a nice trick. We don't need to say the last one. If we want to just go up until the end, we just finish here with the colon and with the semicolon and get our result. Oops, of course I've completely messed this up by forgetting my own, oops, hold on. my own, forgetting a bracket here at the end. And here, lo and behold, we get a stop colon TAA. Okay, so let's do the practice challenges. Try this exercise yourself and stop the video. And then when you're done, come back and I'll go through it together. So if you have done this, hopefully it was relatively easy. But yeah, let's try and get the middle ones. We're starting here with the index 0, 1, 2. And we have to go up until 2, 3, 4, 5, 6. Okay, that should give us G, C, G, T. Okay, I hope this is clear. Let's see if that works. G, C, G, T. Yes. So let's get the first half of the string. Here we can do a nice trick. So we know this string is 8 bases long. So what we can do is we can start. If we start at the beginning, again, we don't need to put the 0 index in. We can do if we want to, but we don't have to. So we can just start with a semicolon, and we know we need to go until 0, 1, 2, 3. So we put 4 as our last one. And that will give us the first half, A, D, G, C. Great. Now, this is a bit more fancy. So there's ways of getting every second or every third item from a list, or in this case letter from a string. If we use this double semicolon, this is confusing me here. If we go here and we do double 2, what will happen is we get the first one, then it jumps over, and it gets the next one, jumps over, gets the next one, jumps over. So we should get A, G, G, A, and that's what we're getting here. Great. If we start with a different letter, then we will get, if we start with a different letter, we will get a, we'll get a different result. We start as T and then we jump, so we get T, C, T, A. This can be extremely useful, and we put a 3 here, we'll go across 3. I must remember not to use the tabs, but to use the keyboard to go for, not F, but 3. So we'll get every third one. So we get T, then it makes a jump of 2, and then we get G. Great. So this works quite nicely. The last one is something that is also quite useful often, is we can reverse things by going around with -1. So if we just say, give me the last letter, we say, give me -1. Or another way, for example, the last 3 bases, we could have said, give me from -3 till the end. And that should give us the last 3 letters as well. So that would be another way of doing the same thing. I know this sounds very confusing, and it's good to practice. I've got loads of practice here in our Colab book, so have a look at that. But I think you trust me, if you do this often and you think about it and you set up a few DNA programs like this, you'll get the hang of this very quickly. Right. We have one more thing to do, which is looping through. So because it's a list of characters, the string, really, we can iterate through it. So we can write a simple for loop. And this is a great place to revisit range and enumerate, which we touched very briefly in the last lecture, but which is extremely useful in Python, and you will start using it. So if we just do a normal for loop, so for I in DNA, for index in DNA, print I. Could have said for base in DNA, print base would have been clearer. We get for each round we print out the letter. Great. Now, there's another way of doing it. So we know the length of the DNA is 8. So we can say, let's look at this range function a little bit, because this is something that we use a lot in Python, and we need to get used to this. So let's just print out for I in range 8, print I. That's very simple. So what will happen here is range will just generate an iterable, at least, not really, but something like a list that starts with 0 and goes until 7. So it's very similar to our indexing. We always exclude the last numbers. We won't get 8, so, but we get 8 data points starting with 0, and it will print it. Okay, so we get 0, 1, 2, 3, 4, 5, 6, 7. Because we know the length of our DNA object, so let's reset this now and say, let's get rid of this here to make this simpler. Because we know the range, we could actually make this a little bit clearer by first saying, sorry, let me reset this. Let's say DNA length equals length DNA, and then and then we could say here range, and that's 8 in our case, and then we could say range length DNA. Okay, that should work as well. Maybe that makes it a little bit more clear. And then for I in range DNA length or length DNA, I'm not going to copy this over again. We print I. So that's basically very similar to what we did before, but instead of the number now we have a variable which could change. If we change DNA here, the program would change. If we add some bases, and we're getting the whole range of the DNA printed out, which is, it's not 8, it's 11 actually, this one. Okay, I hope this is clear. And then the last one is enumerate, which gives you two values. One is where you are in your iteration. So if we start with 0, and the character you pull out in the iteration. So it'll give us the first round, it'll give us 0, because we're in index 0, and A, then 1 and T, and then 2 and G, and so on. And that we can see that down here. And this is quite, if you want to print out more information like that and relate our value to an index, we can use enumerate in that way. Great. And now what we have to do in our iteration, we're not just iterating through, but what we want to do is we want to go, let's go down here. We want to go through, so we want to catch the first base, A, and then see what are the first 3 bases, together with the first A. So if you catch that A, you also want to get the T and the G. Then you want to jump to the next one and capture the T, and then the G and the C. And then the next one, G, C, G, and the next one, G, T, A. In this way, you can get all the codons from all the frames. So that's very useful code in DNA analysis. So the way to do that here is we're doing a for I in range length DNA. So we're going through A, T, G, and then we're getting the 3 bases. So we have the index. So in the first round, we'll have index 0. So we get DNA sliced from 0 to 0 plus 3 will be 3. And then we're getting base 0, 1, and 2. In the next round, we'll be at 1. We start at 1, so we get DNA 1 sliced until 4. So 1, 2, 3, not including 4, and so on. And in this way, we actually get the information we need for our program, because we are hopping along and extracting each codon as we go. And then we can check what does that codon look like, and then direct our program, depending on the outcome, into a new way. And this will be our first encounter with conditionals. So that's what we have to do next. Let's run this. So now we get a nice position ATG, position 0, and so we're hopping along and extracting the triplicate codon sequences out of there, and then we can, at the end, it'll go less and less because we have less and less room, and then it'll finish. But so as we go through this, now the program has to check, do we have an ATG? Then we start now scanning for the stop codon and getting this out as a open reading frame. If we do not have an ATG, move to the next base. So that's a good example for a bifurcation in the program for which we use these conditional if and else statements. Okay, and that we will do in the next lecture. But in the meantime, this kind of operations, it may have sounded very confusing, but if you do it yourself and you get your head around it, it is actually pretty simple. So play around with it, try it, and we'll see you in the next lecture.